In section 6.3, we're going to use similar polygons. So the first thing is what makes polygons similar? What is a requirement? Similar polygons have to have two conditions met. First of all, the angles of similar polygons have to be congruent. Second thing, the side lengths are proportional. So the corresponding angles are congruent, corresponding keyword, but the corresponding side lengths are not congruent, they're proportional. We talked about this a little bit when we discussed triangles and congruency. And if you remember, angle, angle, angle was not a shortcut that worked for congruency of triangles. It didn't mean the triangles were congruent just because they had the same angles. One could be larger or smaller. And as you see here, angles are congruent. A and E are congruent. F and B, C and G, D and H. But obviously these shapes, these figures, these polygons are not. They are similar though. The angles are congruent. The side lengths, not congruent, but in the same ratio or proportional. So if I wanted to talk about corresponding angles, and I do know that they're congruent, I would look at the corresponding angles of E and A, and I know that those angles are congruent. I know that another pair of corresponding angles are congruent. How about angles F and B? They're congruent. I know that angle H is congruent to which angle in the other one? Should be saying angle D, and angle G is congruent to which angle in the other figure? Angle C. And again, I moved those over and showed you that those angles really are congruent. The sides, not congruent, proportional. And so we can write this long extended ratio. A ratio is like A to B, but we're going to look at every side comparison, and we know those ratios should be the same. So if you compared the length of side EH, what does that correspond to in the other guy? AD. That should be equal to or the same ratio as looking at side EF. And I would compare that to what corresponding side in the other one? AB. Should be the same ratio as when I look at side FG. And compare that to its corresponding side in the other guy, which would be BC. And finally, there's one more side length to look at, which is in this shape, HG. And that would correspond to which side over here? DC. Now, each of these ratios would be the same because these shapes are similar. Their side lengths are proportional, and I can write this extended ratio. Okay, so similar polygons. When I ask you what are the two requirements for polygons to be similar, you should say corresponding angles are congruent, corresponding sides are proportional. Look at an example here. Oh my goodness, I forgot to give you the symbol for similar back here. If I wanted to say that these two shapes are similar, list the vertices in the correct order. So I could say EFGH, this polygon, and I went around this way. EFGH is similar to, now similar is just that tilde, that little squiggle. Okay, remember how congruent you have an equal sign with the tilde over it? That's because congruent things are equal and similar, and we're talking about figures. But with similarity, just that squiggle, that tilde there. EFGH is similar to, make sure I start with the corresponding vertex to E, which would be A, and go the same way around. So similar to AB, CD. So symbol for similar there. Maybe I'll draw a little arrow so you know we're talking about that. So now when I go to this example, I know that triangle JKL is similar to, because it has that symbol, triangle QRS. Remember, what does this mean? If figures are similar, their angles are congruent, their sides are proportional. So the first thing says list all the pairs of congruent angles. That was one of my requirements, that the angles are congruent. I'm going to look at that top shape, and I know angle J will be congruent to something. Angle K will be congruent to an angle in the other one. And finally, angle L will be congruent to an angle in the other guy. Now I can look actually just in the statement. If triangle JKL is similar to triangle QRS, then angle J would have to be congruent to the first one here, which is angle Q. So I can look at the statement. I can look at the picture. Angle K would be congruent to which corresponding angle? It looks like these triangles are kind of in the same orientation, so it would have to be congruent to angle R. Maybe for this last one, I'm going to go back up to the statement. Angle L is the last letter. better be corresponding to angle S. And these are congruent angles because they're similar. My next part of this example is I need to check that the ratios of the corresponding side lengths are equal. Now they're telling me these figures are similar. Unless all these ratios reduce the same thing for the sides, it's not actually true. So let's check it out. The side of 25 would correspond to what side down here? How about 35? I know their corresponding sides because JL, first and last letter, correspond to first and last letter here, QS, and yes, that is the correct side. 25 to 35 divided by 10 on top and bottom, we get 5 to 7. This ratio is what I'm looking for the other two sides then. Side of 20 would correspond to side of 28. Those both divide by 4. 20 divided by 4 is 5. 28 divided by 4 is 7. Good, 5 to 7 again. And finally, side of 30 corresponds to that side of 42. Divide by 6, and we get 5 and 7. So yes, the ratios of side lengths were equal. They all reduced 5 to 7. And the last thing here, write a statement of proportionality for the side lengths. If we're talking about the side lengths in a statement of proportionality, it must mean it is a extended proportion, which says one fraction is equal to another. We actually did a statement of proportionality right back here. When you list the ratios of the corresponding sides, and you can add this note to what you did up there, it's called a statement of proportionality. And notice we do just have a really long proportion. One ratio equal to another, equal to another, and one more. So, statement of proportionality here. I'm going to list the side lengths, not the numbers, but the actual segments. So LJ, that side corresponds to SQ. And that would be equal to, notice you could also just look up here if you wanted, LJ, SQ. I could pick side JK, first two letters. That would have to correspond to the first two letters here, QR. JK, QR, and they do in the picture. There's only one more pair of side lengths. I have not done LK. And that would be SR, or I could look here, LKSR. So in the statement or in the picture, but this is a statement of proportionality because I'm listing a proportion for all of those side lengths that is true. And I checked that all their ratios were equal up there. So working with similar figures there. Oh, with similar figures, we also talk about scale factor, just like we did for those proportions in those real life problems. We look at scale. But a scale factor is that ratio of the lengths of the corresponding side lengths into similar polygons. We found a scale factor 3 times in the last example. 5 to 7 is your scale factor because that is a ratio of the sides. Okay? And always reduce to get scale factor. So in this example, I want to determine whether the polygons here are similar. If they are, I'm going to write a similarity statement. Now a similarity statement is what I did right here with that similar symbol in between. So maybe if you want to add that this is a similarity statement here. It's just stating that two figures are similar. And then I want to find the scale factor, meaning the ratio of the sides. Alright, so first, are they similar? What two things do you need for figures to be similar? You should be telling me you need the corresponding angles to be congruent. Are they? I have a 1 arc, 3 arc, 1 with a tick mark, 2 arcs as I went around. Yes, the angles are all marked congruent. The other requirement for figures to be similar is the sides need to be proportional. For sides to be proportional, I need to look at the ratio of all the corresponding sides and make sure you get the same thing. In this case, I got 4 different sides to check. I have to check what the side of 8 corresponds to. That's the shortest side. The shortest side over here is 12. 8 to 12 reduces, divide by 4, and we get 2 to 3. So that's what I'm looking for every ratio. I'm going to go around this way and look at that side of 20. what would that correspond to? Well, that's between the 1 arc and 3 arc. Between the 1 arc and 3 arc here is 30. Divide by 10, also 2 to 3. What about this side of 18? That corresponds to, let's see, between the 3 arc and 1 with the tick mark. Between 3 arc and 1 with the tick mark is 27. Divide by 9. 2 to 3 again. 1 more to check. 22 compares to, the last one I didn't use here is 33. Divide by 11, and you get 2 to 3. Are the sides proportional? Yes. Are they similar? Yes. Because they met the two criteria, the angles are congruent, the sides are proportional. So, write a similarity statement. All right, I will. I will say that DEFG. Again, I could name that a lot of different ways, but the important thing is I named the second one in the correct way. Is similar to, remember that symbol? I started with the 1 arc to 3 arc and continued around. Do the same here. Start with 1 arc to 3 arc. So RSTU. Okay, so the similarity statement is done. And find the scale factor of RSTU to DEFG. Notice the way they wrote this. They want me to give the number for RSTU first, then DEFG. I believe I always took from DEFG first, and then I did RSTU. Now, I actually did scale factor 4 times. I got 2 to 3, but they want the order written the other way, right? RSTU is the larger shape to the smaller. So instead of 2 to 3, I'm going to write 3 to 2 for my scale factor. Just make sure you write in the order they ask you to there. So again, checking my 2 requirements for similarity. Another example here. In the diagram, triangle ABC is similar to triangle GHJ. Find the scale factor. Ooh, okay. Find the scale factor, which means I'm going to compare the 2 triangles and reduce their ratio of corresponding sides. Notice for scale factor, they want triangle ABC first, then triangle GHJ. So I'm going to pick one of these sides in ABC. I guess I could pick 12 or 18. Maybe I'll pick 12. Now side AB, if I'm not sure, it's kind of hard to tell which side to pick here because it's rotated. But I know that side AB, since that's the first 2 letters here, would correspond to the first 2 letters here, which is GH. And side GH is here, or 8. And reduce scale factor. Divide here by 4, and I get 3 to 2. I could also check and make sure this other side would correspond. 18 would correspond to what? That's AC. First and last letter. First and last letter here is GJ, which is 12. 18 and 12 both divide by 6, and you would get again 3 to 2. So we're looking good. Scale factor. Next, find the value of x. To find x, I'm going to have to set up a proportion. So first time I'm using similar figures to find an unknown side using a proportion, but I know all the sides are in the ratio of 3 to 2. Or I could use 12 to 8, or I could use 18 to 12. They're all the same as 3 to 2. But since those are smaller numbers and I like that better, I'll use 3 to 2. And I know that that should equal something with this x. Well, what does x correspond to in this guy? X is the longest side, and I'm pretty sure that's 16, but again, you can check up there. I haven't used the 16 in these, so yeah, that's correct. Question is, where do I put x, where do I put 16? X is coming from triangle ABC, which I wrote first here, so it should be going on the same side of the ratio, or side of proportion as 3. So it should be going on top. Also, this shape was a larger one, the bigger number is on top. Now 16 is with the smaller shape, which was on bottom. At this point, I know I've set it up correctly. Again, did I have to use 3 to 2? No, I could have used 12 and 8 and put those sides there. This is just a reduced version of that, so it's fine. Either way, you'll get the same answer. I put x and 16 in the correct spots because x and 3 came from the same triangle, the bigger one. 2 and 16 came from the same triangle, the smaller one. Cross multiply to find x. 2 times x is, of course, 2x. 3 times 16 would be 48. and divide by 2, and it looks like 48 divided by 2 would be 24 for x. Does that seem like a reasonable length for that side? I'd say so. This side was 18, that'd be 24. Looks good. So talking about similar figures and the requirements for similar figures, that angles are congruent, sides are proportional.